And so it is. Welcome to a thing we don't really do very much. So what we're going to do is I'm going to walk you through how I would approach a very real code challenge that somebody got for an interview. This was a toughie too, and kind of covers a different area of tech than we normally cover in the program. The program is about application development. That's why we call it full stack software engineering. But that's not the only kind of programming that there is. There's also systems programming and lots of other things that don't necessarily have a ton of overlap with application development. And you very well might be asked to solve problems like this, as they're real common in interviews. So I'm going to show you what this challenge is. This is redacted and a little bit simplified from the one, but it's the same programming difficulty, just a little bit less explanation. So the goal is to write a function that takes a string with 1 to 4 characters, ASCII encodes them, pads the result to 4 bytes, and then scrambles the resulting bits in the following format. So as an example, if you put A in here, this is the ASCII binary code for A, and then you want to pad that out to 4 bytes, and then you want to scramble them. And so the way they have you scrambling it is like this X goes here, this W goes here, this V goes here, this U goes here. So you're always starting with 32 bits and ending with 32 bits, but you're trying to scramble them in this pattern. And then, last step, you take this resulting binary number and represent it as a decimal. So as an example, Fred outputs this 2 million, 25 million, whatever that is, decimal. And that's how it gets to it. So what I want you to do before we get started is I want you to see if you could sketch out how you might do this.
Can you explain like what some of those terms meant? Like what is padding? If you're saying you're taking
So if we just take this blue part right here, that's 8 bits. 8 bits is 1 byte. And we'll talk more about this when we start working through it. 8 bits equals 1 byte. And we can represent any ASCII character with 1 byte. So ASCII characters are lowercase letters, uppercase letters, and a couple of symbols. So that one is what A is. Padding something means adding blanks so that we always have 4 bytes. If we got 4 bytes, like we did with Fred here, cool, use them. If you only got 1 byte, we need to add these empty bytes in here also so that our scramble still works. Other questions? The real difficulty of this is this part right here. JavaScript has nothing for working with binary numbers. And so you can't just put them all in a string and then try to rearrange them that way. That, of course, would be too easy. So you have, once they're binary numbers, you kind of have to keep them that way. Any other questions about what's being asked of us in this challenge? Cool. Go ahead and start sketching out a solution. So this is way above code. Come up with high-level steps that you think you would need to do to get from the input to the output. I'm going to give you a couple minutes. Okay, let's see how far we get through this. So the first thing that I would do if I was given a situation like this is set up a testing environment. This one ends up decomposing into a bunch of smaller pieces, and the only way you can keep track of it is with tests. So I have this empty folder here. Nothing up this sleeve, nothing up this sleeve. So I'm going to do this in JavaScript, and the actual challenge, they give you like your choice of languages. I kind of regret choosing JavaScript, but I think it's probably the one that most of us know. So I'm going to npm install Jest, and while I'm at it, I'm going to install ESLint also. So Jest is a JavaScript testing framework, and it's nice because it kind of combines a bunch of different testing tools in one easy to use package. And then ESLint is for cleaning up our code. So I
What language
will.
would you do this in, Kyle?
What was this?
What language would you do this in if you had to choose?
Probably Go. I think Go lends itself well to a problem like this. I don't know the C languages too terribly well, but they'd also probably be a pretty good fit for this. But like all of the scripting languages, Python, Ruby, PHP, like they're pretty poor fits for something like this. But Go is like just the right amount of low level. Okay, so I've installed Jest and ESLint. I'm going to make a test folder. I'm going to make a, let's see, I can make the spec first. I'm going to call this index.spec.js. And I'm going to make the file we're going to work in. And I'm going to go into that package. Oops, did I get a package JSON? What? Oh, I didn't npm init, that's why. Cool. Reinstall those. There we go. And then I'm going to set up a test command. Cool. So to test, we're going to run Jest and then watch all. And so what this will do is it'll just keep running our tests for us every time we change something. Then I'm going to split the screen. Like that. And I'll show you why I do it this way. This is a Tmux trick. You can also just do this with regular Windows with VS Code and in a terminal or something like that. But I really like doing it this way because I can just keep an eye in the corner over here. Oops, that's the old one. What do we call this? Hard CS code challenge. There we go. Run npm test here. I can just keep an eye in the corner here and see when something turns red or green. And then if I want to see why it turned red or green or whatever, I can just swap those panes. So right now it's telling me, yo dog, you ain't got no tests. So that's a fixable problem. If I describe the encoding examples, it returns the correct decimal value for A. So that's example 1. And then, so the way we'd write this test is, all right, what would what would this look like if it worked? So we could say that the input is A. That's what they gave us right here. And then the output is a number. It's 16777217. And then we just say expect encode input to equal output, like that. That's it. That's like the kind of test that you write for this sort of thing. And what's powerful about this is that it goes, cool, encode is not defined. Well, of course it's not. We haven't written it. We just said that when this works, that's what it'll look like. So, all right, well, how would encode be defined? Well, we'd probably import it in from that main index file, like that. Cool, so now I have another error. Well, encode isn't a function. No, it's not. So I go over to that index.js file, and I module.exports encode, and then make it a function. All right, what do I get now? It goes, cool. Well, I was expecting this number, and what I got was undefined. So a good sanity check here, and there's actually like good testing philosophy behind this generally. Just try like hard coding that return value. So you could say something like return, what was it, this. And then I got a green test. Cool. So now I just need to make this true, because as I write these other ones, I can get that first one to pass, but I won't be able to get the other ones to pass too. The other ones are Fred, Fred is supposed to return 2517. And then 92692. And then this last one was space, colon, caret, parentheses. And it's supposed to return 7909 and then 4888. So if I do all of those, even hard coding the thing, I can't get them all to pass at the same time. All right, neat. So if you're starting a code challenge, I would start with something kind of like this, because now, without even like working on what the solution is going to look like I've set this up like a Learn Lab or something where it'll tell me when I do it right. And as I'm starting to decompose this problem, I can start to see whether things are actually returning the things that I think they are. Okay, cool. So we're set up here. Now I want to think about how I would go about doing this. So you can start at either end. I'm kind of inclined to start at the end and work backwards from there. So the end of this is, all right, if I have this binary number, can I get it to show up as a decimal number? So like assuming that I have something like that, can I get it to read as 167777217? And hard part about that is that it's, like I said, JavaScript really doesn't have any tools for working with binary numbers. But I want to pause for a sec and talk about binary and bits and bytes and that kind of stuff. Some of you probably know this already, but never hurts to review. Who can tell me what a bit is?
0 or 1 Boolean value.
Yep, 0 or 1. It's not exactly the same as a Boolean, but pretty darn close. So 0 and 1. That's a bit. Can anybody think of why we built this whole computer shit around binary?
Because you could build more complex logic off of just that when you start stacking them on top of each other.
Well, we can represent numbers that way. And once you can represent numbers, you can do stuff with numbers. So like these bits, this is like each character in binary. So if we've got something like 1, 0, 0, 1, 1, 0, 1, 0. Okay, so that's a binary number. And it maps to a decimal number. If we go, okay, so that's the number. That represents 1. That represents the amount, whether or not there's a 2 in this. This represents whether there's a 4, an 8, a 16, a 32, a 64, or a 128. So if there's a mark there, then we go, cool, add it up. If there's not, we don't. So we could say, all right, it has one of those, it has one of these, it has one of these, and it has one of these. So this number is 64 plus 16 plus 8 plus 1. Cool. So this number right here is 89. We can represent any number from 0 to 255 with 8 binary numbers. So I'm going to go back to my original question. Why? Why did we do these binary numbers for computers?
On and off.
What was that?
On and off.
On and off. You're right. Keep going.
Circuits function with electricity, and we can only show whether something's turned on or turned off.
Yeah, it's easy. So if we go, all right, if there's any electricity present, we'll call that a 1. If there's no electricity present, we'll call it a 0. And in reality, it's thresholds. It's like if it's over 3 volts present, then we call that a 1. If there's not at least 3 volts present, we call that a 0. And if we pulse those, we can represent numbers. And so that's how we can start doing math and stuff with beeps and boops, just little pulses of electricity. It's pretty cool. So then we can combine those into numbers just like we would with decimals. And we can say, all right, we have 8 bits. Well, that's a byte. Or you could say we have 32 bits. And that lets us do numbers up to however big, a few billion. And then we could have 64 bits, and that allows you to do numbers way, way, way bigger than that. Cool. So that's just a little bit of bits, bytes, and Booleans. All right, so what we're trying to do is be able to take this binary number here, this 32-bit binary number, and get it to return whatever the output is. So the next thing that I would do is write a test for that. So you can take this, we're just going to set it aside for a sec and skip it. And then we're going to describe like binary to decimal. And then we come up with some things that would let us know whether or not our binary to decimal worked. So why don't we just use the examples that they gave us? it converts, let's see, 16777217 from binary to decimal. So we would know that this worked if we could call, let's see, input is going to be 7 zeros and a 1. 1, 2, 3, 4, 5, 6, 7, 1. And then all zeros. And then all zeros. And then ends in 1. Like that. So that's how we're going to represent the binary on this. They told us to not do it like a string, because that would be like that. Don't do it that way. That was part of the rules. So we're going to represent it as an array of zeros and ones. And then we're going to say that the decimal of that is 167777217. And we're going to expect that if I call binary to decimal with the binary, then it will equal the decimal. Cool. Hey, what do you know? It failed. Why did it fail? It's a syntax error. Glad we caught that. All right, binary to decimal is not defined. You're right, it's not. All right, now it's wrong. It's not a function. It's fixable. Okay, still not a function. Cool. So now it's returning undefined instead of this number. All right, well, we can get that to pass, and we got a green test. So I'm going to say we should probably start with a simpler one. So we can say, I want to skip that and say it converts 1 from binary to decimal. Shoot, how about 0? So that should otherwise kind of work the same way. So this is where we start fleshing out this implementation a little bit. So
I have a question about that. So you're saying if it converts 0, I mean, then you just did an array with one term. Wouldn't it need to be like 0 written out with all those? You know what I'm saying? Like isn't the whole point of the algorithm that you're working with? And I could be like, I'm obviously wrong. I just want to understand why I'm wrong.
Sure.
As far as like, doesn't that need to be the same size where it's, I guess, 16 digits or something like that?
Not necessarily. So a byte has to be 8 bits. A 32-bit binary number needs to have 32 things in it. But that's not what this is doing. This is just taking any binary number and giving you its decimal value. So a single 0 in binary, still 0 in decimal.
Okay, but you're saying that. I think the thing that I'm confused about is, I thought that that algorithm that you're going to wind up making doesn't change depending on the size of the array that you're putting in.
What do you mean?
I guess maybe I'll just watch you do stuff, and maybe my answer will be solved.
All right. I'm trying to turn a binary number into a decimal number. That's it. So if I have a 0, I should get a 0 back. All right. what if I did something like, so I take binary and I go, okay, if, let's see, how would I do this? So this one's a little bit tricky. You do something like, I want to reduce this like that. And really, if I'm just doing the first one, that'll probably get it to pass. Nope. Let's see, am I running this? It's taking that in. Oh, I see why. So we're going to take the sum, and then we're going to take the bit. And here's the thing you may not have realized you could do with reduce in JavaScript. You can give it a third argument, and it's the index. That's going to come in handy in a sec. And then if we return the sum, all right, we got a passing test now. Sweet. So now I want another example, like the next level of complexity. Maybe it converts 1 from binary to decimal. Oh no, I got a failing test now. So I'm going to say, all right, how would I know whether or not I should, how I sum this? And here's the magic trick. I want to take, if I think of, oops, where is this upside down? It's holding it upside down. Let's say I was taking this in as an array.
Did you flip the array before you process it?
What?
Would you flip the array before you process it so that way the index represents like the exponential?
Correct. So first thing that I would do is flip this around. So we reverse it. Cool. And then I want to check to see that, like, as I'm iterating through this, so this one is actually this like little teeny bit here, and that's going to be index 0. So the way that binary numbers work mathematically is you say something like, all right, if there's a bit, I want to return sum plus math.pow, and I'm going to take the number 2 and raise it to the index. So the first thing that's going to happen is I get the like the 0 there for that first test. So I'm passing a 0 in, and I raise this in there, and if you raise anything to the 0 index, it's 1. All right, hey, that's real handy. That's exactly what this first position in binary is supposed to be. All right, for the next one, the index is 2. All right, well, if I take that and raise it to the power of 2, all right, well, I get 4. Like, it just keeps going like that. So we can do the, we can do some cool math like that. And I can probably do this as a ternary. I can say, if there's a bit, then I want to return that. Otherwise, just keep the sum what it is. So that's gonna, when it's a, when there's not a bit, I don't add any numbers. When there is a bit, then I figure out whatever that position is going to be and then sum it together.
If you don't provide like that else kind of option in a reduce, it breaks it, right?
Correct. All right. So cool, I got passing tests. Sweet. So let's see if we'll do that like big beastly one now. So those are passing, good. If I don't skip that one, all right, something I didn't like. All right. So didn't add these up. So good. So tell you what, let's keep skipping it, and then let's keep making this more complicated and see if we can figure out why that one isn't working. Say it converts, what's the next one? Next one would be like 3, or maybe I'll just do 2. So 2 would be 1 and then a 0. I'm trying to make those match. Does that match up? That does not. See how much easier that's going to be to troubleshoot than that is? This is our destination. This is where we're trying to get. But just like this is our destination, and this is where we're ultimately trying to get with this code challenge, small pieces. Let's work with easy stuff. And if we get all the easy stuff to work, my hunch is we'll get some hard stuff working too. So, all right, let's see what it thinks we're doing. All right. Expected 2 and got 1. Ah, it's because I'm not reversing it. Cool, now I got green tests. So that makes me think, if I do that, hey, I got green tests. So if I ultimately somehow generate this correct binary number, if I call binary to decimal on it, I trust that that's going to give me the correct output. That's the thought process behind this. I'm going to pause there for a sec. What questions do you have?
I think the most confusing part for me now is the wording of how they said that it has to be 4 bytes.
Sorry, say it again.
I think the most confusing part for me now is how they said it has to be 4 bytes and where that constraint comes in, or if we've tackled that.
Stop. Eventually it needs to be 4 bytes. You can't solve the entire problem at the same time. The entire craft of programming is decomposing stuff down to smaller and smaller and smaller pieces. So JavaScript doesn't have any way to deal with binary numbers. Cool. So before I get anything else done, I need a way to represent binary numbers as decimals.
Gotcha, that makes sense.
That
Yeah, I wasn't sure if we need to tackle that part of it yet. Okay, cool. Thank you.
Is dealing with binary numbers, is that like a common question in technical interviews?
I don't know if it's common, but in this case, the example they gave is we might be dealing with proprietary data formats, and this might be stuff coming over networks. And let's say you're writing a video encoder. Guess what? You get bits. You have to work pretty low level. So there are things that do this. You don't run into it in application programming almost ever, which is why JavaScript and Ruby and Python all have such shitty ways of handling binary data. That doesn't mean nobody ever has to deal with it.
Dealing with this in the form of an array, is there a level of abstraction that makes it significantly slower than, you said Go would be a preferred language?
Go would run circles around this.
And is that because it has operations that are specifically built for binary?
That helps, but the bigger problem here is that JavaScript is getting compiled down to C++. We're using all these arrays and objects and other shit so that we can write this code, and then all of that is getting compiled, and then all of that is getting compiled. We're adding extra layers of abstraction on top of it. Go doesn't have those. Go is its own language. So that would do it orders of magnitude faster.
Thank you.
Cool. The reason for reversing the binary again, Jack, was, yeah, you got it. So we see it like this, but as I iterate over it, I'm trying to use that index to figure out what the exponent needs to be. And so I want to work right to left because I want that to be the ones place, and that to be the twos place, and that to be the fours place, and that to be the eights place. So I need to flip this around so I can use the index to help me out with that. Good question. Cool. Onward. So, all right, continuing to work backwards. So if I have this binary number here, then presumably I can get that output. All right, so now I need to figure out, can I get to this 32-bit binary number given this 32-bit binary number? So we're going to call that like scrambled bits. That's essentially what it is. So if we're describing scramble bits, then there's going to be a input binary, and it's going to be, we can take their examples again. So 3 empty bytes, or octets, I guess would be a more appropriate term for it. And then the last one ends in a 1 and has a 1 in this position also. All right, so that's our input binary. We want to generate an output binary. So this one also has the 1 at the very end, but this one is a 0, and this one is a 1. Cool. So then if I should expect that scrambled bits input binary should equal the output binary. And shocker, it doesn't. Doesn't exist. All right, well, that's a solvable problem. Scramble bits. All right. Scramble bits. Scramble bits. So we'll call that our input binary. And I'm going to return something. All right, cool. Doesn't like the response. Perfect. So I know that there's like a mathematical relationship with mixing these things up. We might get there one of these days, but for right now, let's just figure out how to get some tests to pass. So one of the things that I would do on this, if it's always going to be 32 bits and position 1 is always going to go to position 2, position 2 is always going to go to position 5. Okay, well, we can make a mapping of what the input is and what the output should be. And in JavaScript, that's easy. It's just an object. So I'm going to say the mapping is this. You may not have realized that you can use integers as keys and objects. You also might not have realized that you can make just about anything a key in JavaScript. You can make a function definition a key in JavaScript. It's wild, super flexible. But we're going to say that like position 0 goes to position 0. We'll go with offsets so that like our loops and stuff work a little bit better. So there's going to be 31 more of these. And then these should just kind of increment like that. And the way this is going to work is that, okay, so 0 goes to 0, 1 goes to 0, 1, 2, 3, 4. So that one's 4. Number 2, number 2, V, goes to 0, 1, 2, 3, 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay. Well, this has given me like, now I have a pattern that I can go off of. So that one's 12, that one's 16, is 20, 24, 28. And then these go in little 8s. So that one's 8. And then this next one goes to 1, and we do it again. 5, 9, 13, 21, and 31 is the last one. That's what we're trying to get to. We'll know we did this right if when we get to the bottom, 31 is 31. This one should be 25. This one should be 29. All right, next up is 2. And then 6, 10, 14, 18, 22, 26, 30. All right, and then our last octet is going to be 3, 7, 11, 15, 19, 23, 27, and 31. There's our mapping.
Can you go back to the problem statement just so I can read?
We're
So,
scrambling the resulting bits in the following format. So they gave us a little key of how this works. And then the things that I'm doing here, the number on the left is the index of how it starts. The number on the left is the index of where it should end.
you're purely just looking at their position.
Correct.
The content, it doesn't matter.
Exactly. It's just switching up their positions. That's
Is
all we
that,
have.
is that generally the case when they say scrambling? Or is it just something you gotta keep an eye out for on each problem?
Well, like, scramble is not the technical term for it. We're just mixing stuff up. And like, you wouldn't actually write an algorithm that just does this unless it's like the world's shittiest hashing algorithm. No, that's sorry, the Kyle Coberly hashing algorithm's the shittiest one. But no, that was the problem they gave us. Can you mix these up?
Okay.
Sorry, can you explain further why you're offsetting everything by 4 and how that matches the key?
Yeah. So I figured that out. So like they use like these letters and numbers here. They're not actually the letters and numbers. They're just trying to help you visualize how this position shift happens. This X stays in the same place. This V goes to here. Or sorry, this W goes to here. This V goes to here. This U goes to here. And so when I did the first couple of these, I was like, oh, we're just incrementing by 4 each time. And so that's where I got the 4 from. It's just a pattern recognition. It doesn't even count as math. And then
You're just
But-
following the format that's given, right?
exactly.
Because it
That's
could be
the count.
anything.
Yep, it's all we were asked to do is follow the format. This P ends up going here. This N ends up going here. So they're just kind of interleaved together like that. So the first bit of each of these 4 bytes, second bit of each of these 4 bytes, and so on. And that incrementing by 4 thing, I just did the first couple and was like, oh, I see the pattern here. Now, there's probably also like a mathematical relationship that we could derive here, but I'm not smart enough to figure that out. I just hard coded the mapping.
Cool, that makes sense. Thanks.
All right, so I have this mapping. The thing that I'm trying to do with it is take in this input and make it look like that output. So what I'd probably do, what I call these variables, input binary. So I could do something like, my easiest way is just make a new array. Like that. And then iterate through my input array. So like, let I equal 0 while I is less than input, we call it input array, input binary. We'll call that output binary. Input binary dot length, and then increment I at the end. All right, for every one of these, output binaries, like its index 0 should be equal to like input binaries 0. That's the shape of this, but I can't hard code it every time. I need to generate those like positions dynamically. And so I'm trying to do whatever I is, but this one doesn't stay 0 every time. This one gets calculated with that little mapping. So I want to take that mapping and go, all right, how about, sorry, whatever index that I'm currently on, look up what index that should be. So when this is 0, my very first iteration, I look up 0 and it goes, cool, well, that maps to 0. So output binary ends up being output binary index 0 is the same as input binary index 0. The second time it loops through, I is 1. So mapping at 1 is 4. So then that becomes, all right, output binaries 4 should be input binaries 1. And then that's going to be 8. And that's going to be 2. But that should flip those around. What I think.
Did
All
you
right.
do like a range map?
What was that?
Did you do like a range and then a map on that range like we did the other?
Yeah, you totally could, but I probably wouldn't with things like this. At least get the test green first, and then you can play around with refactorings and stuff. But part of red-green refactor is getting to green. Don't get clever with it. That's how you tie yourself in knots, is like trying to write good code. Write gross code. Just get it green. But before you move on, that's when you're trying to make it good. In this case, that actually looks all right to me. I'm not too worried about it. Because like as we get lower level, our cool like enumerables and abstractions and stuff make a little bit less sense. Use whiles and fors. Confuse you less. All right, so hey, I got a green test. Hey! So that means I can successfully mix these up. So if, oops, and I did that all in a describe. Input, it should scramble the bits from example number 1 correctly. So if we want to get a little bit more confidence that we did this right, then we could take their next example, see if that one works. So we make a copy of that one, and say it should scramble the bits from example 2 correctly. So example 2, 0, 1. So this was the input for that, 0, 1, that, and then 0, 1, and then it ends in 0101. And then in the third byte, it's 0101. Oops. And then 0010. And then the last byte is 0100. That's 110. All right, so that's the input. The output is supposed to be that for the first byte, 1011, and then 3 more ones. Oh, wait, no, I didn't do that right. I'm looking at the wrong one. Come on, man. Let me just sanity check myself. All right. So the output for Fred is supposed to be all ones on the first byte, on the second half of it, and then only that one there. And then the third byte, 1101. That's how it ends. And then in the last byte, those two, and then that, and then that. All right, moment of truth. If we wrote this right, it stays green. It stays green! If we fuck it up, does it break? It breaks! Cool. So, still just working in teensy little pieces backwards. If I somehow had that 32 bits, could I generate the 32 bits they're looking for? I also know that if I have the 32 bits they're looking for, I can turn that into the number that we're ultimately supposed to have. So now the next question is, how do I get these raw bits? And so those come from an input string. So we get something like A, and then we're supposed to generate something like that. So I think that the next thing that we need to do is be able to get the binary representation of one of these characters. So we'll call that like character to binary. So we'll describe character to binary. It should encode A in binary. And so the binary representation of A is 01000001. So we'll say input is A, output is 0, 1, and then a 1 at the end. 2, 3, 4, 5, 6, 7. There we go. So I should be able to do something like character to binary input, expect that equals the output. Shocker, it doesn't. Character to binary. Cool, it's not a function. It is not defined. character to binary, takes in a character, and I just return it. All right, now I'm getting something a little bit more familiar. Expecting this, and I just got the string back. All right, so to map these together, I need to figure out what that character is in ASCII. So you know how we use meta charset UTF-8? UTF-8 is a character encoding. So what that means is it maps a number to a glyph. UTF-8 in particular looks like this. All right, if you give me a 1, give me this empty character. If you give me a 21, give me an exclamation point. If you give me a 30, give me a 0. If you give me a 55, give me a capital U. So it's just a map of those things together. That's UTF-8. UTF-8 is huge. It is all the Latin characters, lots of Chinese characters, Greek characters, like the emojis are all characters in UTF-8. There's tons of them. ASCII is much shorter. This is it. Just these characters. It's 127 of them. And then like a couple extras because you can use an entire byte for it. So these are the other things you can do with it. All right, cool. Man, how am I going to get these character codes? Am I going to like type this table out by hand? I certainly could, but JavaScript does give me a pretty good tool for that. If I'm taking in a character, I can do character.charcode@, and that's going to give me its ASCII value. So if I do a P or whatever, that's a 50. All right, cool. Well, if I have that, then I just need to find a way to make 50 binary, and that should give me the thing. So I have decimal or binary to decimal. I need the opposite of this now. I need one called, well, I'll write the test first. I need decimal to binary. So what we do is skip those tests for right now. And describe decimal to binary. So we could say something like it should encode 0 as binary. Always want to start with your easiest cases. And so what that would look like is that. And maybe I want, it's kind of up to me whether I want just like the raw binary or if I want the whole byte back. I'm going to say the whole byte for right now. So I want that. So I should expect that decimal to binary input should equal that output. Hey, it doesn't. It's not defined. Now that we're getting a few of these, we can start breaking them up. What do I call this? Decimal to binary. And then over here, so this one is probably the gnarliest one math-wise, but guess what? You're not the first person in history to figure out how to convert a decimal to a binary number. So you can just look up how somebody else did it and copy theirs. But basically what you need to do is test if it's 0 first, because nothing works like if you have that. So you go, all right, if decimal is 0, then return the empty bit, or empty byte, I mean. All right, it's green. That's our first case. It should also like be able to do 1, how about? And that would look something like that. Okay, so the trick here is that you do a while loop, and you say while the number still exists, you want to like have your binary thing like start here. While that number exists, you're going to take the remainder of, see, it's number divided by modulo math.pow 2 to the shit. How does this work? All right, I'm just gonna look it up. There's no good reason to memorize this. Binary to, or decimal to binary. Algorithm. Perfect, right here. So like this is in Python, but this rem stack, God, I hate when people write these programmer abbreviations. Stack is just an array. It's an array with like a couple neat properties to it. So that's going to be this thing up here. Remainder is, that's not math.pow, it's just modulo 2. And then you're going to push the remainder in, and then you're going to make number equal to, so that double like divide thing, Python has a shorthand for math.floor and then divide. So that's math.floor number divided by 2. Yeah, that's it. And then we return the binary. All right, so let's see what we got. Number is not, oh, it's decimal, sorry. Oops. All right, cool. Hey, check this out. I got my 1 back. I'm missing these pads. All right. So that tells me that I should pause the rest of these tests and make something that takes a binary number and pads it some amount. So I could say describe pad binary, and it should not pad a full binary number. So our easiest case is just like, well, it doesn't fuck anything up. So maybe I expect that pad binary input is 0, 0, and padding the input by 2. So when you say pad, you're saying it needs to be 2. If you only give me 1, make it 2. If you gave me 2, leave it 2. So this should, it's 2 equal input. So we're just hoping that that leaves it alone. And pad binary is not defined. So we make a pad binary that takes in a binary number and the size that it needs to be, and exports it. So I think about how we would do this. It'd say something like if binary.length equals the size, then we just return it. And that gives us a green test. So now let's like try to make it do something. It should pad a 1 position number to 2. So if I have that, I'm expecting it to give me back that. So, oops, what did it, oops, output. Cool, so doesn't pass, cool. So if it doesn't match the size, then
On your test, you're only inputting the number and you're not putting in the size, or did I miss that? Oh, just
the
kidding.
size is right there.
I was reading the wrong part.
Cool. So I want to do something here like whatever the size is, like any difference between those, I'm just like adding zeros to it. So maybe that's something like, let's see, how would we do that? Give me some ideas.
You could do a while loop.
Yeah, sure. Walk me through it. What am I doing in here?
If what is it? You're basically comparing it to size.
Yeah.
Then you're going to increase the size of every loop.
Yeah, so maybe like while binary.length is like less than size or something
Right.
like that.
Mm-hmm.
Yeah, and then I like decrease size each time.
Yeah.
Okay, so what do I do in between?
Add a 0 or push a 0 into the binary.
And that's the tricky part. I don't push it.
Oh,
I don't know
you
what those numbers look like.
shift.
I shift it
Yeah, you put it in the front.
because I want to put it in the front. So I binary unshift it, something like that. Oh, and then I need to return it. Hey, I got a green test. One of the things I like about doing tests like this is I am terrible at figuring out if it should be less than, or equal to. And so if you do it wrong, doesn't even matter there. That's pretty cool. Because I only have the 2. But as I like write another test case for this, the test just let me know which one it should be. So if it should pad a 1 position number to 8, then I say something like that, and it should be something like that. Oop, good catch. So I'm padding that out to 8. If I take the equals off of that, oops, still doesn't like it. So I'm getting the first 5. Oop, might be doing something wrong altogether. So I gave it 1. So, and I want it to be 8. So binary length 1 is compared to 8. It's not. All right, so we move on. All right, while 1 is less than 8.
Because it keeps checking the length of the binary when you unshift it.
Oh, good call. So what I should do is put length out here like that. Hey, I got a green test. Cool. And if I got like my less than or equal to wrong, it fails. That gives me some context, some confidence that I did this right. All right, well, now that I have that, we can start working back up.
Can you explain why that didn't work? Was it because it was comparing binary.length? It wasn't actually updating that each time?
Well, so it gets down to the bottom and it goes, so I've made the binary thing longer and now I'm comparing the size of it. So I'm like lowering the size. So I've made the array bigger and I'm shrinking the size each time. So it only does half as much as it's supposed to.
Okay.
Cool. So now that we've gone down and down and down and down, we have all these tests that we've kept skipping because we have another piece of implementation to do. Now we can start like trampolining back up. And let's put this back. Let's get that failing test we had before. And it goes, all right, yo dog, you gave me an array with 1. It's supposed to be 8 things long. So now I can say decimal to binary. I can do something like pad binary 8. And I got green test now. Pretty fucking cool, right? All right, so we gotta like get to feelings, but the this is the idea of this. We're like already like we did all the hard parts. So if we get this last number here, we can turn that into the output decimal. Give me this binary number, I'll give you this decimal. We can also scramble. If you give me this binary number, I'll give you this binary number. Cool. We also made it so that if you give me the character A, I can give you this binary number. And I can make sure that it's always a full byte also. So the next thing that we would do is, all right, well, if you give me Fred, I can give you this array of characters for that, and then we can scramble them up. The last piece we'd really need to do is if you give me less than 4 bytes, can you pad out the rest of the bytes? So if the list of bytes is less than 4, can you add enough blank bytes and then scramble it? Well, that's fucking easy. Cool. Give me some takeaways from this.
There's a lot.
Evan,
There's a lot of little parts to it that you have to test as you go.
there is, but they're all little. Every single one of these things we did is teensy tiny. They're like whiteboarding Wednesday level problems. The trick is figuring out how you can break a really complicated problem into stuff that's that size. More takeaways.
I had a kind of sidebar question. Like, was this like a screening thing where you can run tests on your own computer? Or is this like a whiteboarding thing? And like,
No, this was a take home.
Okay, and so like take homes, you should figure out. You should learn how to write tests as you're solving those.
Mm-hmm.
Cool.
And like writing good tests is very difficult. Writing these kinds of tests a little bit less so. Like you can think of them just as your placeholders. Instead of console logging everything or putzing everything, just say, all right, well, what would you have wanted to see if like you console log? And just write a test for that. Writing tests for applications is much, much harder. Writing these kinds of tests, a little bit less so.
Gotcha.
What was the nature of the role that I was applied to or for this interview? Because it kind of reminds me of working with IP addresses and networking. I'm just kind of curious.
This was a consulting position.
Was it specific to an industry or like a
No.
technology? Okay.
No, it's like this is the SWAT team that your company hires when like you have something that your engineers don't know how to do or something like that.
When do you think a good time for us to start learning these testing techniques would be as on
The next time that you like are working on a challenge like this, see if you can write tests for it.
Okay.
Like even if like you're still in mod 1, take a look at those RSpec tests. Just copy paste an RSpec test in, see if you can change things and get them to pass without breaking.
What's a good resource for learning how to write those tests? Is there like a learn module for it or anything else?
Ooh, that's a good question. I would, for these kinds of tests, fuck. There is a learn module. It's not very good. For JavaScript, if you go to jestjs.io, they've got pretty good walkthroughs on using Jest. RSpec's docs, I think, are pretty good too. This would be the same thing for Ruby.
The Codecademy has like a test-driven development module I was gonna work through this week.
Yeah, and like, so yeah, I did everything through test-driven development. I wouldn't start there. That's turning on hard mode. I would say while you're learning testing, every time you want to console log something, just write a test first. See if you can, at least. That'll help. What else?
I thought the way you started at the end was super interesting.
Yeah.
I would have started like, how do I get A to the ASCII character? And you started from how do I get this binary to this binary thing. That's really interesting.
Yeah, in general, I think working problems backwards prevents a lot of wrong paths you might go down. It technically doesn't matter. You could have done this just as effectively the other direction, but I find that I go down a lot more rabbit holes when I try to go that direction.
I thought it was interesting how like there could be problems that look simple, but then there's like a lot involved. Like I worked through like a like trying to come up with a way of determining how many days are between dates. So that's actually like a pretty complicated problem.
Yes.
But it sounds like on paper it sounds simple.
Yes. Okay, if they're not out already, I'm going to send out surveys. Let's do surveys, and then we'll start finishing up the day. Thank you much, everybody.
Thanks, Kyle. Super informative.
Yeah, I'm glad.